Hi folks, quick video helping with adjusting Degg models for Unit 4. Now the Degg model is from 1991 and it weighs up how a disaster is created by a hazard combined with a vulnerable population. And we're going to look in this video at how you can adjust the Degg model to make it work as a comparative tool rather than just a theoretical tool. Okay, the original Degg model, 1991, just gave the idea that if you add a hazard to a vulnerable population, you will get a disaster. Because if the population is vulnerable, the hazard will affect them very badly. You'll get the disaster in the middle. That's all very well and good, but it doesn't actually give any complexity. It was never designed in this form to give an accurate figure. It's more just a theory as to how disasters are created. However, we can take it a step further and we can adjust the Degg model so that we can use it when comparing disasters from any type of source, whether it's tectonic hazards, tsunamis, earthquakes and volcanoes, like you'll be using in Unit 4, or if you're resitting Unit 1, you can also apply this to hydrometeorological disasters as well. So what we have here are two hazards. Now, in order to adjust the Degg model, we can actually adjust the size of the circles in the Venn diagram that the model uses. The Venn diagram, of course, being the two circles overlapping. If we adjust the size of the hazard and the vulnerable population and the amount of overlap, we can use it as a comparative tool. For example, these two hazards are different sizes. Now, it could be that they are two hazards that are the same, like earthquakes. They could be the same rating on the Richter scale. Or it could be that they are different hazards but of a comparable size. So it could be that they are both very, very high magnitude, even if one's an earthquake, one's a volcano, or one could be an earthquake, one could be a tsunami. It could even be a hurricane that's at category 5 and an earthquake that's category 9. Regardless, you can adjust the size of the circle like that. That's quite obvious. The next stage is to think about the vulnerable population. Now, the size of the vulnerable population depends on basically how many people are going to be put in the line of fire. If you've got a larger population in an at-risk area, then the circle is going to get larger. However, it might not just be that there's a larger population. It may be that out of a whole population in a country, a lot of them are poor, or a lot of them live in risky areas. So you could be looking at one of the least developed countries where there might be a few rich people and many, many poor people. And that would give you a relatively large vulnerable population. Now the lower one, it could be that that is a very small population in a country, or it could be that most people aren't vulnerable. There's only a small number of people who are vulnerable and they make up the vulnerable population. Either way, they are going to be affected by this hazard that's coming in. Now this is where the real strength of the adjusted model comes in. We've got our two vulnerable populations. However, the disaster is the amount of overlap between hazard and vulnerable population. This means the more that the hazard overlaps with the vulnerable population, the more of a disaster you have got. Let's look at the two example models to compare this. Now we've got our vulnerable population. This could be, for example, a large number of people who are poor and at risk from hazards. However, there's only a very small amount of overlap between the circles. Now this means the disaster is small, so perhaps very few people have been killed. Reason for this could be that they were very well prepared. For example, Cuba, where individuals are very well educated and very well prepared for a hurricane coming in. They're all very vulnerable because they're relatively poor and it's a very low-lying island. However, because they know what they're doing, there's a very small overlap. In fact, if it were Cuba, I'd make the overlap even smaller. What we've got at the bottom, though, is a small number of people who are very vulnerable but have been affected by the hazard. So we've got actually a larger proportional disaster there. Now this could be, for example, like the Boxing Day tsunami, where a lot of people didn't see the tsunami coming or didn't know what to do, and they were caught by it, whereas a few people escaped. Again, I'd probably make the vulnerable population slightly different, except I'd make the bubble larger there, but I would have about the same amount of overlap. So the difference here between the standard Degg model and the adjusted Degg model is that you can actually compare two different hazards against each other, and you can compare the effects, making it a very powerful tool. So as a recap, on the adjusted model, hazard size is the magnitude of the hazard. The vulnerable population bubble size is the potential people affected, so the number of people who are at risk. The overlap, though, is the size of the actual disaster. Now I would recommend making Degg models, adjusted Degg models, for every single one of your case studies. It makes them very easy to compare if you do this. Now obviously tsunamis, earthquakes and volcanoes can't be directly compared, but think of the hazard size as a rating out of 10. So for example, a magnitude 9 earthquake would be either 9 or 10 out of 10 because it's the largest that has been experienced. You could think of something like Yellowstone erupting, potentially, or even something more like Pompeii or Krakatoa erupting as your maximum volcano strength. And you could go for a Boxing Day tsunami as your maximum size of tsunami. And if you set all of those at 10 as examples, you don't have to use those examples, but if you set those all at 10, you can then work out, relatively speaking, how big all of the others were. If you do that, it makes it easier to make these diagrams, and it gives you a good indication of how the physical and the human have interacted together. Any questions, let me know. Thanks for watching.